All right, here's 7-7, day 2. Because a logarithm is an exponent, transformations of logarithmic functions are very similar to the transformations of exponential functions. You can stretch, reflect, translate the graphs of the parent function of a logarithm. Transformations of the natural log work the same because the natural log means a logarithm of base e. So the first type of transformation is a vertical translation. That happens at the end of the equation. So if we have a plus 3, it'll move it up 3. If we have a minus 4, it moves it down 4. Horizontal translations, left and right, happen inside the parentheses, inside the function. So minus 2 moves it right 2, plus 1 moves it left 2. And I always say, think opposite. On those. Vertical stretches and compressions are multipliers in front of the function. So if our number is greater than 1, it's going to stretch. If our number multiplied is a fraction, it's going to be a compression. Notice the horizontal stretch and compression is crossed out. At Eastridge High School, we don't teach that type of transformation because it's not a state standard. The last type is reflections. When the negative is in front of the function, it's going to reflect across the x-axis. If it's inside the function, it's going to reflect across the y-axis. So here's an example where we want you to graph the parent function of our logarithm. So notice that the parent function is a common log. Its base is 10. So what we do is we evaluate the function. So we substitute this into our calculator. And I would pause and try this now. And what you're going to get is an error. It does not work because it's outside the domain. So the domain for a logarithm of any base has to be x values greater than 0. So then again, if we substitute 0 into the calculator for a logarithm, it will not exist because it's not greater than 0. Then we substitute 1 in, and we get 0. So the order pair is over 1, up 0. Then we substitute 2 in, and we get 0.3. So we get the order pair 2, 0.3. Then we substitute 10 in for the logarithm, and we get over 10 up 1. So what does this graph look like? The first order pair is over 1 up 0, over 2 up a third, over 10 up 1. Looks something like that. Now with logarithms, they're going to have a vertical asymptote, and that vertical asymptote is at x equals 0. So again, the domain is going to be x greater than 0. The range of values will be always all real numbers.